Hi, good morning everyone. Welcome to the another session of playing with numbers. Today under the playing of numbers we are going to test the divisibility of some numbers like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in this regard, so it's also beneficial for when you are doing the prime factorization of any number. So before checking the prime factorization of any number, you check the divisibility. Here we are discussing about how we check the divisibility of a particular number, whether this number is divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because many numbers are there, like bigger numbers are there are many digits will be there, so it will be very hard to find the which number should be divisible by this number. So in that case there are some rules are there. Here I made the table according to that. So here this is the serial number divisibility test. Which number we are going to do the divisibility test, what are the condition in which divisibility test will be done, and example. Okay, so in this, if first I have to check divisibility of 2. So how we check the divisibility of 2? If last digit of the number is even, like one place, unit place number is even, like 0, 2, 4, 6, 8. So that number we can directly consider that number is divisible by 2. Like for example, I have 128, that is divisible by 2 because last digit is 8, and when you divide 8 by 2 you get the whole number. When you get the whole number, not 0, we not consider as 0. So here if you consider the whole number, so that number is divisible by this number. If in the remainder is left after division, so that means that number is not divisible by that particular number. Like in 129, last digit is 9, we check only for the 9. When you divide 9 by 2, then you left the remainder 1. So that means that is when you going to write, that is not possible. Proper division will be there and remainder is left. If any number remainder is left, that means that number is not divisible by that particular number. So if you divide 129 by 2, so in that case also remainder will be left 1. So instead of checking with the whole number, we only check for the unit place digit, that is 9. If that number is divisible by 2, give you proper answer as remainder as 0, that means that whole number will be divisible by that particular number, like 2. Like in 128, when you divide by 2 or only check for the unit place, 8 divided by 2, you get the answer 4 as the quotient and remainder is 0. So that means that number is particularly divisible by 2. Similarly, here when you check for the 9, when 9 divided by 2, that doesn't gives you remainder 0. So that means that number is not divided by 2. So if there is 3-digit number like that, x in the 100 place, y in the tens place, and z in the unit place, to check the divisibility of 2, so only condition is that if unit place z variable is there, so z should be divisible by 2. So this is the check of the divisibility of 2. Next is how you check the divisibility of 3. For checking the divisibility of 3, whatever number is given to you, you add all the digit, whatever digit present in the number, you add all the digit. After getting the addition of the digit, what number you get in the answer, if that number is divisible by 3, so that means that whole number is also divisible by 3. Otherwise, if it is whatever, like here 2167, so if I add all the digits, I got 16, and 16 not comes in a 3 table, so we can directly say that this number is not divisible by 3. So if similarly, if I have 3-digit number in variable form, 100 places x, 10 places y, and unit places z, so you have to check the divisibility of this number. So just pick the digit placed in the particular position, like x, y, z. You add this x plus y plus z. If this addition is divisible by 3, you can easily get that number is divisible by 3. Now you have to check the divisibility of the 4. If the last two digits are divisible by 4. If you have to check the divisibility of 4 in any number, doesn't matter how big a number is this, we check only for the last two digits, not only one digit, like ones place digit and 10 place digit. Or when you check with last two digit, if that number is divisible by 4, gives you remainder 0 and proper quotient, so that means we can say that that particular number is divisible by 4, like 13,612 is divisible by 4. Similarly, if 3-digit number variable is there, then 100x plus 10y plus z. So in that case, you only pick last two digits, like 10's place digit and 1 place digit, and check for the divisibility of the 4. If it is divisible by 4, you can easily say that that number is divisible by 4. Now next is divisibility check of 5. If any number last digit is 0 or 5, you can directly say that you no need to check by division. You directly say that this number is divisible by 0 or 5. Like herein also, if I have a number 100x plus 10y plus z, that is divisible by 5. So that means last unit place digit, ones place digit, if it is divisible by 5, so we can easily say that that number is divisible by 5. Like next is, if you have to check the divisibility of 6. If the number is divisible by both 2 and 3, if there is a number is 6 has, if you go with the factor of 6 is 2 and 3 also. Okay, so if you check the divisibility of 6, then you can follow both the rules of 2 and 3. Whatever divisibility test of 2 and whatever divisibility test of 3, if both apply on this number, so we can say that that number is divisible by 6. Like I have a number 17,214. I only pick the one place digit, unit place, that is a condition of divisibility test of 2 and 3. So here that number is divided by 2, yes, and if you add all the digit of this number, that gives me 15. 15 is also divisible by 3. If both condition true for divisibility of 2 and 3, we can directly say that that number is divisible by 6. Similarly, if you have 100x plus 10y plus z divisible by 6, then this whole number will satisfy the condition of divisibility test of 2 and 3. If both condition is satisfied, then we can say that this particular number is divisible by 6. Now next for the 7, divisibility of the 7. If we double the last digit, now whatever number is digit present and unit place, you have to double that one. Okay, or you multiply by 2 or add similar number in same number and subtract it from the rest of the number. Whatever other number is left, you subtract the double of that number. If your answer is divisible by 7, then you can say that that number is divisible by 7. Like here, if I have 672, I just pick the unit place digit and I make the double of it. 2 plus 2 4, or 2 into 2 4. So that double number is subtracted from the remaining digit, like 67 minus 4. So that gives me 63. 63 when you divide by 7 gives me 9 as remainder 0. So that means 672 is divisible by 7. Similarly, if this has digit places number are there, like 100x plus 10y plus z is divisible by 7, so we can say that we have to pick this x and y, but not consider as 100x and 10y, because when you remove z1, so only 2 digit will be left. So according to that, like here in 6 7, so that becomes unit place and that becomes 10 place. So we consider that number as 10x plus y, or 10 into 6 plus 7 minus 2 times z. 2 times z means whatever number present in the unit place is here, you multiply that number with 2 and subtract from the remaining number. If your answer you get that is divisible by 7, so that gives you divisibility of the 7. Now divisibility of the 8. If you want to check the divisibility of the 8, you check for last 3 digits. Last 3 digits, 1, tens or 100 place digit, and if that number is divisible by 8, then you can check whole number will be divisible by 8. Similarly, if you have a bigger number like that, 1000 place w, 100 place x, 10 place y, and unit place z. So if you want to check the divisibility, here you only pick these hundred place, 10 place and unit place number, and if that number is divisible by 8, we can say that that number is divisibility by 8 and divisibility test is true for 8. Now you have to check the divisibility of the 9. If sum of the digit is divisible by 9, this test is same as your divisibility test of 3. There also you add all the digit. Here also we have done the same thing. If you have add all the digit, and what answer you get, if that number is divisible by 9, so we can say that that particular number is divisible by 9. If that number is not divisible by 9, we can directly say that that particular number is not divisible by 9. Like 1629, if you add this number we get 18. 18 divided by 9 gives me 2 and remainder 0. So that means that number is divisible by 9. So you just directly say that that number is divisible by 9. So you can directly go with divisibility of 9 with that number. Like here, if I have a number 100x plus 10y plus z is divisible by 9, so that means you just pick 100 tens and unit place digit, add this and check with the divisibility. If it is divisible by 9, so divisibility test is true for 9. Now how you check with the divisibility of 10? You directly go with the last digit. If the last digit is 0, so we can directly say that this whole number is divisible by 10. Now divisibility test of 11. So how we'll check the divisibility test of 11? We divide the number into two parts. Whatever number is given to you, you mark the digit, position of the digit above that number. Like here I have 3729. I mark the position, 3 in the first position, 7 in the second position, 2 in the third position and 9 in the fourth position. After that you just separate even or odd. I mark it here like 2 and 4 positions are even position and 1 and 3 are odd position. So whatever even position numbers are there, whatever odd position digits are there, you separate those digits and add them. Like here also even position is 3 4, I add 3 plus 4, and here also odd position numbers 1 plus 7, means you separate odd or even position numbers, add them separately, and when you get the answer then subtract them. Like here even position number 7 plus 9, I put it here, then between sign is negative, and here after that odd position number is added. So addition of even number minus addition of odd position numbers, when you subtract these numbers, whatever answer you get, if that answer comes in 11th table or divisible by 11 properly gives you remainder 0, so that means that number is divisible by 11. Like in here also in the formula, how will you go? Like w, x, y, z. W in 1000 place, x in 100 place, y is tens place and z in unit place. So here when you got the position here, w is in first position, x in second position, y in third position and z in fourth position. Second position numbers are x and y, x and z. So second position and fourth position number, even position number, you add x plus z first, and after that odd position numbers are w and y, you add them also separately, then subtract with each other. If your answer is either 0 or whatever number you get that is comes in 11th table or divisible by 11 properly gives you remainder 0, so we consider that that number is comes in 11th table or divisible by 11, or test of divisibility of 11 is true for this number. After above all tests like up to 11, one more condition is there, factor of a number. Factor of a number means how you check the divisibility test by if you have bigger number is there, like 12 is there, 14 is there, like that. So if I have a number 6, I also check with the divisibility of 6. So under 6 it should be verify the divisibility test of second and 3 both. Like factors of 6 is 2 and 3. So whatever factors of those particular number, so that divisibility test will go on that particular numbers, like particular factors. If number divided by 6, then also divided by 2 and 3. And if any number is divided by 12, then it also be divisible by factors of 12 is 2, 3, 4 and 6. It means if you check the divisibility of any number, so condition is that that should also be divisible by factors of that particular number. Thank you. Have a nice time.